Welcome to Tech Primers. In this video, we are going to see a little bit of information about Apache Spark. So, what is Apache Spark? What does it do? So, how does it differ from Apache Hadoop? And internally, how does Apache Spark works? And what is the life cycle of an Apache Spark? And what are the different terms involved in manipulating the data using Apache Spark? And also, finally, we are going to see some live examples using Apache Spark. So, I have downloaded Apache Spark. We can do something about that. So there are some documentations in Apache Spark website. So we are going to use that documentation to literally bring up a Apache Spark server, and we are going to try that uh, Apache Spark computing engine. So let's do that. So before going into what is Apache Spark, so if you are familiar with Apache Hadoop, these are different tools for querying big data. So basically these are different tools for processing and transforming big data and mining them and getting meaningful information out of the huge amount of data which you have. So previously if you see Hadoop was the big thing, but Hadoop also has performance issues. That is what Spark is overcoming with. So let's see what is Apache Spark, right? So basically what is Spark? So Spark is an open source cluster computing framework which was created by a group of people, okay, to overcome what was a problem in Hadoop. Okay, so what internally Spark does is it does real-time data processing with huge amount of data, which basically Hadoop is lagging with. So if you know about Hadoop, Hadoop can do batch processing only. However, Apache Spark can do real-time data processing as well as batch processing at the same time. So it can be used for real-time data processing as well, and it can be used for batch processing as well. So initially, Spark was developed by people from the University of California in the which is in Berkeley. That's called AMP Lab. So I don't know the full form. I think it's somewhere something like Algo Machine or Machine People or something like that. So they created the Spark framework there, and later on they moved that to Apache Foundation. So that is why it is now called Apache Spark. So initially it was just called Spark. Okay, so now there are lots of active community, there are lots of people who are contributing to the Spark community, and it is growing day by day, and it is one of the highly valued frameworks in the big data world now currently. Okay, so why use Spark, why not Hadoop? So as we just discussed, right, so the map reduce solves only batch processing problem. However, Spark does real-time data problems as well. And also the other thing to mention is Spark is almost 10 times faster than Hadoop. That's what they claim. So and that is how the stats reveal. Same way as I mentioned, Spark solves the general purpose computing system, which is real-time data and batch processing both, but Hadoop does only batch processing. So that is a major advantage of Spark. And also the number of lines of code which you write in Spark is less compared to what we wrote in Hadoop. So Hadoop, if you know, it was written in Java, but Spark is written in Scala. So Scala is another language which is written over the JVM with the functional programming in idea, right? So if you see the Scala code, it is all functional. So with Java 8, Java is now moving to functional style. However, Spark did that earlier. So Apache Spark is like, sorry, Scala did that earlier. So Apache Spark is written on Scala. Okay. So what does Apache Spark is composed of, right? So initially they have a Spark core library. So that is what is going to control everything. So it is like the heart of Spark. So over that we have Spark SQL. So that is like a SQL interface kind of thing using which you can query Spark core, or you can even you can query everything. So you can use SQL like syntaxes to query Spark. So that is the Spark SQL. That is one part of it. Same way the next one is Spark streaming. So you can query streaming data from Spark using this. You can query and put both. Basically you just put the data and then get it back. So the next one is machine learning library. So mlib. So that is one part of Spark as well. So there are machine learning libraries inbuilt in Spark so that you can use them to do some machine learning related operations. Finally, graphics. So if you want to do graphic related storage and you want to retrieve store data in the form of graphical representation, then you can use that as well. So these are different core components inside Spark. And finally, how do we get the data? So we get the data using data frames. So the data frames abstracts all these out. So using the data frames, we have to get the data from Spark. So this is generally the high level of how Spark is built. So this is how Spark's internal looks like. Okay. So what are the different components inside a Spark? Now that we saw what is there in Spark, what are the different components inside a Spark architecture? So how does Spark maintain these resiliencies and failures and stuff like that, right? So Spark has something called a driver. Okay, so the driver is like a master. So that is the one which is going to command everyone saying, okay, do this and do that, something like that. So inside the driver, we have something called Spark context. So this is similar to the application context if you had used a Spring. So this is going to have all the data which we store or something like that. Okay. So then these Spark contexts are going to control the worker threads or the worker nodes basically. So inside the worker nodes we have executors, and these executors basically execute some tasks. So there is a driver which acts like a master, and the driver instructs the workers to execute some tasks. So that is all done by the Spark context. So Spark context instructs the workers to execute some tasks on each node. Okay, so if a particular task fails, that gets rebuilt and Spark context rebuilds that and sends it to the worker again. Okay, so that is how fault tolerant is handled. So how fault tolerant is handled, we are going to see that what technology they use and what concepts they use. So that's it about the components. So there are different abstractions which are done in Spark so that you don't know what's happening internally. So you don't have to know what component does what, how it is done and stuff like that. So we are going to see what are the different abstractions. So the first one is the resilient data distributed data sets. Basically these are called RDD. So this is the core component of Spark. So whenever you are operating on any data, you will use an RDD. Okay, so that is called resilient distributed data sets. So these are nothing but data sets which are reconstructed on the nodes. So these are basically data which gets generated whenever you want to do something on that on a data. Okay, and then if there is a failure, these data gets reconstructed every time. Okay, so this RDD gets reconstructed every time. These are basically immutable data, and then you can do some transformation. Let's cover that in depth in the coming slides. Let's move to the next abstraction. So the next abstraction is the data frames or the data sets. So this we would have heard right from the previous slides. So data frames are nothing but an abstraction which is going to cover up all the Spring Core, SQL, streaming, and machine learning library which Spark has. So data frames is another level of abstraction which is provided by Spark. There is something called D streams as well. D streams are for Spark related streaming API. So that is nothing but an API. So D streams is another API which we use for stream processing. Okay. So now let's see what is RDD, right? So we, as I said, RDD is resilient distributed data sets. But what are these used for? So these are used for transforming data. Okay, so these are used to generate data sets on which you can transform data. So if you see the definition, right, the transformations are generated as acyclic, directed acyclic graph. Basically, RDD uses the concept of DAG. So it uses DAG to transform objects or transform data sets. Okay, so the DAG can be recomputed during failure. So whenever there is a failure in the node, whenever there is a failure in the worker or the executor thread or the node, these DAGs are recomputed. Basically they are recreated. Okay, and finally there are transformations happening on this particular RDD. So what are the different types of transformation? There is something called map, there is something called filter, there is flat map, there are text files, etc. So you would have heard all these in Java streams. So these are just transformation techniques to transform data from one type to another. So these are just general concepts of transformation. So that is why you see the same names: map, filter, flat map, and text file. Okay, so that is RDD. So RDD is going to be the key for us to transform data using Apache Spark, and internally it can use map, filter, flat map, and stuff like that. Okay, and as I said earlier, these are immutable. So once you create an RDD, you cannot change it. So let's say when you are querying a data in the cluster, so whenever you do a RDD creation, it gets created and it is immutable. So when the data gets updated on the cluster, this RDD has to be reconstructed, okay, or recomputed basically. Okay, so that is why it is immutable. So RDD is immutable. So it just creates a snapshot of the data at that instance. So it creates a data set from that instance at that particular point of time. Okay, now let's move to the life cycle in Spark. So how does a typical life cycle in Spark look like? So how do I put the data? How do I get the data? So how do I need to do that, right? So the initial part is loading the data. So that is when different data sources come into picture. So you can load streaming data. You can load the data from the database, any database like Cassandra or relational database, or even the HSQL. Sorry, the HDFS file system. So you can or even the S3, Amazon S3 system. So all these are loaded as data sources into Spark. So it can accept any type of data source. So whether you have file system or the relational database or the key value store or anything else, so if you have the data stored somewhere, it can be loaded as a data store using the data sources. Okay, the next one would be the transformation. So once the data is loaded, we need to transform the data. So transformation is what is going to play a key role in transforming these data. So using the transformation, we use the map. For the transformation, we use the map, filter map. We would have seen that, right? So once the transformation is complete, we have to perform an action on the transformed data. So that is what action means. So once you, let's say you are going to filter out some data, so you have a collection of let's say vowels collection, you have you want to filter out only A or E. So then you do some operation, that is transformation, and then finally you end it saying, okay, I am done, just collect this, or group by, or do something with that, reduce it, or just compress it. So that is an action. And finally, whatever data we have got, it should be pushed to the UI dashboard for real-time analysis, or it can be persisted for future usage in the form of processed data, because these are processed, right? These are processed at that particular instance. So this is how a typical life cycle of Spark looks like. So if I convert this into points, so load the data into the cluster, you need to create RDD. So once you have created the RDD, you have to do transformation. Once you have done the transformation, you have to perform an action. Once the action is done, you have to create data frames out of it. Using the data frames, you can query the data, okay, or you can even run SQLs on the data frames. Okay, so that's it about Spark. So let's try what Spark is, right? So let's go ahead and try Spark. So I have installed Spark already. If you, it's not an installation as such. It's just a binary download. So I downloaded Spark already, and I have just unzipped it in my downloads folder. So this is the current version of Spark which is out there. It has Spark 2.1, and then it said it had Hadoop 2.7 inbuilt. So I'm not having any cluster, nothing. It's just plain laptop. I just have a MacBook Pro. So let's try what it does, right? So I'm in the bin folder. If you see, let's go to the structure of the Hadoop package. So you have jars, you have notice, you have yarn, you have sbin, you have Python licenses examples. These are different folders where these are pre-packaged and given for us. So there are some examples as well. So we are going to see those examples from the documentation which Apache has provided. So for now, we are going to first go ahead and start Apache Spark. Okay. So in order to do that, we need to run a command called spark shell. Okay, so where am I? Am I in the bin folder? Yeah, so I need to run a command called spark shell. Okay, now I need to provide, what is it? It's a master, and I need to give the host where it needs to run. So it's the local host, and I'm going to say that I need only one thread, right? Okay, I don't want to kill my machine. Okay, it's a very old machine, but yeah. So I'm just saying local one. So let this start up. Meanwhile, let's go to the documentation and then see. Okay, so if you see here, this is the Spark website, so spark.apache.org, and I'm just in the latest documentation, doc/latest. So if you see here, whatever command I ran, it is present here. So you can also run Spark interactively to a modified version of Scala. This is a great way to learn the framework. So this is how you run. So master option specifies the master URL for a distributed cache. So this is nothing but the URL for the cache. So or even local to run the locally with one thread. So yeah, so this is how you run one thread. So I'm just saying that my local is the master for the distributed cluster, and I have only one thread. That is what I have done here. So and this instance is going to be run as a Scala shell. So if you see, I have started it as a Scala shell. If you are expert in Python, you can use Python shell as well. So okay, so if you see here, the process has come up. If you see here, this is the log of Spark. So it is just throwing some info logs. Failed to create a global database, returning no such object exception. Okay, Spark context web UI available at something. So it is saying that okay, there is a web UI available for Spark at this particular URL. I don't know, I have never tried it. And same way, there is something called Spark context available as SC. So this is what we saw in the diagram, right? If you recollect the diagram, we said there will be a Spark context which is under a driver, and that will be managing different executors. Okay, so that is nothing but this Spark context. So and you can access that using SC. So if you see here, this is a Scala interactive shell. So this particular command, like the Spark shell, has internally got the Scala command line interface. So this is basically coming from Scala. So since Spark is written on Scala, so they have integrated this shell into Scala, into Spark itself, so that we can do some operations in the Spark directly here without even having to write a new program as such. So the next, there is something called Spark session available as Spark. So you can use Spark to access some Spark sessions. So meanwhile, let's go to the URL. I don't know, I haven't checked what this URL shows. Okay, so this is just showing what are the different, it's showing some event line. So it okay, it's just like showing we, oh okay, this, look at this is the executed thread which we saw, right? There is it's saying that executed driver added. I'm not sure what does it mean. Maybe we can try running some example programs, and I think these jobs should be showing some event timing data. Okay, so what I have done is I have gone through this documentation, and I'm just going to the quick start guide, which has given me some examples of what I can do. So for example, we have this Spark context, which is the SC. So using Spark, how can we do some operations on a file, right? So first, as you know, what we have to do is we have to do the RDD. So basically you have to load the data and then create an RDD. Okay, that is what we are going to do here. So what I'm going to do is, there is a file called readme.md. I have opened one more tab here. Okay, and this is the same folder, and I have already created a file called readme.md, and it has the content of hello YouTube. Okay, so let's go to this. So what we are going to do here is we are going to read that readme.md file. Also there is a readme.md in the previous folder. We can actually we can go and read that file as well, because that has more content. So let's see if it works. So what I have done is I have just executed the command val text file equal to sc.text file of whatever. So this is a Scala syntax. If you're not aware about Scala, it's okay. Even I don't know Scala. It's just similar to Java, but it is slightly different than Java. But let's, for our case, we are going to understand Spark. So in order to understand Spark, you need to understand Scala as well. So I would suggest you go ahead and learn Scala as well. So I am also going to do that. But before that, to understand what is Spark and how we can do things in Spark, we can just do some basic Scala coding. That should be okay. So as if you see, this is readable, right? So we are using the Spark context using a text file. We are just reading a readme.md and storing it something called text file. So and if you notice here, the log which Scala has sent us, or the Spark has sent us, is it has created a RDD, okay, with readme.md, and it has created a map partition RDD1 at text file. So basically this text file is, the object is created now, and we can use that text file. Okay, so what I'm going to do now next is you can if you see that life cycle, what we did, what we said. So first we have to create a RDD, then you have to transform the data, then you have to do some action on the data. So I'm not going to do any transformation on the data. I'm just going to say what is the count of the text file. So basically this is going to return the size of the text file. So if you see here, it says long 104. So this text file is nothing but the file which is there in the previous directory. Why space is like creating issues. Okay, if you see here, this is going to return the size of the file which is there in this particular directory. So this particular file, if you notice, it is huge. So this is nothing but the readme file given by Spark itself. So that is what our transformation or the action has resulted in. Okay, so what we did is we just did an action, and then this is now returned a result for it. So this text file is now still there. So this is nothing but a RDD, and it is immutable. It is not going to change. Even if you change the content of the data, this is not going to change until you recreate the RDD. Okay, now let's do some transformation on this, right? So let's do some transformation on this data. So there are some samples which they have given already. If you see here, in the this is the documentation from the Apache Spark website. So what they are saying is do a text file dot count. This is going to return the number of items in the RDD. Maybe different for your readme, will change over time, similar to the other outputs. Okay, so that is what we did. We just saw the count of the size. So now next what we can do is we can get the first line in the file. So basically you can directly do that in Scala using the text file dot first. So that is what we are going to do now. Dot first. So this should return the first line. So if you see here, Apache Spark was the first line, right? So if you notice this file, yeah, Apache Spark with a hash was the first line, and that is what we got here. That is what we got it as a string. Okay, that is the result. So what we have done here is we have used Spark to read the file, transform, and then finally create an action, and then we got the output. So now let's do some complicated task, right? Now let's do some transformation. So if you notice here, we have the text file. Okay, we are going to use filter and then identify what are all the file lines which has Spark in them. Okay, so what are all the lines which has Spark in them? So that is what we are going to do here. So let me type this. So I'm going to say text file lines. I can create any object. I'm just saying text file lines. I'm using the text file and I'm saying filter. Okay, filter every line where line dot contains Spark. So wherever there is Spark, this is going to be filtered. Okay, so if you see, there is an RDD created for this as well. So there is an RDD created for text file and it is immutable. Same way now there is an RDD over this. Okay, now we can just say text file lines. Okay, this will just return the RDD because we didn't do any action on it, correct? So we did create only the RDD, but we didn't do any action on it. So we need to perform an action and then only we will get the result. So if you notice here, this count and the first, these are all actions. So we can do some action over this. Okay, so if you notice here, count is a type of an action. So if you see here, count is a type of an action. So we can do that. So this should return the number of lines which are there with Spark. If you see, the result is 20. So the number of lines which are there inside the text file lines is 20. Okay, so this is an action. So now you know what is RDD, right? So RDD is a immutable object which gets created from the data which we extracted basically. So that's why RDD is like a data set. So it's like a resilient distributed data set. You can create multiple RDDs from a same RDD. That is what we did here. From a text file RDD, we created text file lines RDD, and over that we just did some action to get some results. So for example, we did a count and we got some results. So that is an action. And using this data, you can either do dashboard what do you call reporting, or you can do store it again back into some other data source. Okay, so that is what this covers the whole life cycle, right? So first what we did is we loaded the file, Okay, this is what we did. And then we used RDD. Using the RDD, we created some transformed some data here, and then finally we created an action, and then we saw the data which got filtered. Okay, so that is the whole life cycle. If you see their website, they give other examples. There are some complex operations like using map and stuff like that, but you guys understood the concept, right? So this is how Spark works, and this is nothing but the interactive console of Spark. And you can even load Java programs in it, but this is just the interactive shell which I am showing right now. So right now I will not cover the Java loading part, that I will cover in the next video. But this is what Spark is all about, and this is why Spark is great, right? So you saw that how much time it took for me to write a Spark program. It was very simple, right? Isn't it? I just started the Spark console, and then I just started writing already the Spark related coding. Okay, that's it for this particular video. Hope you guys understood what is Apache Spark and the internals of what it is doing and how it is doing. Meet you again in the next video. Until then, thank you.